Alright, I'm going to be reading from Genesis chapter 7, verse 11. In the 600th year of Noah's life, in the second month, in the 17th day of the month, the same day were all the fountains of the great deep broken up. The windows of heaven were opened. Welcome to another class of New Year's Cosmology class number 19. The Fall of Lucifer, Part C, Fountains of the Great Deep. Alright, so today, what we're focused on is the last class. We've had a couple classes where we're talking about the fall of Lucifer, and we talk about the makeup of the earth. Now, the fall of Lucifer is symbolic. It is not exactly the same as the spiritual fall of Satan. I know a lot of Christians have gotten after me about that. But essentially, when you understand the Christian zodiac, and we talked about this in class number 16, what you'll find out is that these things are a symbol of the gospel and the greatest story ever told. And so these are signs and wonders, and one of the signs was Lucifer in a gamma ray burster that came down and went to destroy the earth and ignited what we know as the Great Flood. And so we're going over that scenario. You really got to keep on going back from point 1 now to class number 19. Okay? These things are all in order. And I try to make them so that they can stand on their own. But what you have to understand is the fact that people come in at like class number 12. And then they'll say, well, but you didn't talk about this, this, or that. I'm like, well, I did in the previous classes. So you have to work your way through all these concepts. I mean, you can skip ahead, but then you just got to keep on going back, okay? Everything's made in order and logic. Now, what we're dealing with today, first thing is we talk about, why is the Earth and the continents shaped the way they are? The current theory is called plate tectonics. And I really think that plate tectonics was designed to prop up uniformitarian geology. And we'll really kind of talk about that more when it comes up. But essentially, it is to help out with problems of uniformitarian geology. And it's also there to help out with explaining issues like why there's so many of the same species on all these different continents that they're supposed to be separated by millions and billions of years. So plate tectonics, it starts off saying that all these continents were billions of years ago, they were all part of one big supercontinent. And they call that continent Pangaea. Okay, here's an illustration of Pangaea. Yay! They're all put together in harmony. They're all one. Okay. And so you have Eurasia right here. This little thing. That's all that right there. Now, I got to be honest with you, though. This is not perfect to scale either, okay? Because the Earth is round. I know it's... A lot of people want to argue about that nowadays. But anyway, yeah, so basically it's not perfectly to scale, but it's still... as Trump would say, huge, okay? So, it's a huge territory. And then when they look at this, there are weird things. Look at Australia, how weird that looks, okay? You look at that again, or just rewind it. And then here's Australia there. India, or they're calling it Indy, it's kind of perverse over here. Antarctica just gets shoved up in there. But essentially, they would assume that that's how it's going. Young Earth creationists, essentially, a lot of them seem to be of the mindset to where there was a lot of electromagnetic reversals going on at the time, and that just caused the plate tectonics, but they just caused it really, really fast. Now, there's a couple things, though, that it just don't add up about the plate tectonic theory in general. Okay. Number one is the issue of the seafloor spreading. What you'll notice here, and I'll show you another map in a second, but there's this mid-Atlantic ridge that's wrapping around the Earth like a baseball. And what they're going to argue is that that ridge, it's got, some volcanic activity. And so this volcanic activity had lava come, and it would push the whole ocean to the side, and that would push these continents aside over billions and, millions and billions of years. Now, the problem with that is that volcanic lava, now it's hot and nasty, okay? I mean, you don't want to get anywhere near it. But as far as the power of volcanic lava, it's the consistency of oatmeal. Okay, it's like the oatmeal is pushing the continent. Just give the oatmeal billions of years, and it'll shoot everything over. And it doesn't look right. But let's look at a couple other maps, because these maps, the real problem is that you're just seeing what's on the surface that's not covered by water. You're not really seeing how these things really work out. Now here, this will show us the ridges, okay? So let's take a look at that. Make sure I've got everything covered here. Alright. Of course, you're watching YouTube, or maybe I get this on DVD one day. And so just pause it. Pause the video, take a look at this stuff. You see, there's things that are underneath the ocean, and there's different levels. Some places are only a couple feet deep. Some places are miles deep. So if there is that much depth, what is sliding is going to be affected by those things. It doesn't make the perfect match that we're looking like, because there's other layers of ground underneath this stuff. So, the Yucatan Peninsula is only so deep compared to the Atlantic Ocean. And so you would find Earth if we just lowered the water levels. And let's see here. I saw another illustration. Here's another illustration of the difference of these water levels. Okay. Now, so that's another big problem. Underwater land bridges. This is all connected right here. That's all connected right there. The Earth, it's got all these things in it to where this stuff seems pretty well fixed. But we also see some other things where it seems like it wasn't always that way. And that's where we're going to start explaining some of the things, the hydroplate theory. And also some of these, with the New Year's cosmology, we're not just taking hydroplate, we're also taking some other things. And the electric universe guys are starting to come out with some really neat advancements in the field of geology with magnetics. So I'm going to talk about that. But the proof of these plate tectonics would have to be that they say that the ridges of the different plates is what causes earthquakes. The problem is that they miss. Sometimes they're way off. I live in Kentucky, and we're not on any connecting plate, okay? The plate, we're right in the middle, okay? So there shouldn't be any earthquakes. In my lifetime, there's been about 3 or 4, okay? And then a couple small ones outside of that. So that should not have happened, according to this theory. But who needs evidence when you got a great idea? So basically, they go along with everything, and that's where all the momentum builds. It's a big ideology. The plate tectonics, the uniformitarianism, the evolution, Big Bang Theory, it's all connected into one ideology. And so you're going to see that continuously pushed. But this is all, as I said, to back up the geologic column. Now, the geologic column is a very small part of the Earth. You have the crust, and then we'll talk about the mantle. And I believe, sometimes when you're talking like this, it's kind of hard to go through and quote everything personally, but I'll put down the notes. But anyhow, I believe that you have the crust would have to be the granite layer, and then underneath that you have the basalt layer. Now, this is only one particular area, okay, the geologic column. And, it's just a one little area they dug, supposedly. But basically what you find is that the geologic column is supposed to be what they believe that all Earth's history was. But out of all their sites, only 1% are really dealing with these different layers. And so with that, or they're actually dealing with the column at all, I should say. So basically, how do you explain the rest of this stuff? Well, you do it by plate tectonics, all right? But even then, where do we find the geologic column? In your geology textbook. Because you're not going to find it if you dig, okay? It's just not been happening. There's been 15 to 20 claimed sites, and of these, only about 6 of them were given out any records. I mean, ultimately, the only place that really, seems to have any sure thing, I thought there were 2, one in China and one in North Dakota. Turns out, just the one in North Dakota, all right? They're all missing columns, or they're not in the right order, okay? But you could go to this one up there, and you can find the columns in the right order. It sounds great, but there's only one problem. You see, according to this theory, all these columns should stack up to a certain amount. And in order to have the amount of Earth history they claim, this 3.3 billion years and all these hundreds of million years for life, well, in order to kind of have that kind of stuff, it should be about 1 to 200 miles deep. Well, they don't have that. What they're showing you, okay, with that one location, all right, is they're going to show you about a mile, maybe a mile and a half, 3 miles tops, all right. But basically, they're not showing you any of this history that's supposed to be there, all right. And geologists talked about that a lot. These are all based on paleontological finds, and that's probably another discussion that we'll have in a later class. But another thing I noticed, I said, we have all this energy that's come down in this gamma ray burster. Okay, this thing has just hit the Earth in this scenario, and it's converting over to many types of energy. And of course, we're dealing with an electric universe theory, so we're dealing with these ideas of electromagnetics. And what do you see? You see these Birkeland current shapes. Okay, you see these squiggles going down here? They're all kind of coming out there. Look at that. Even the mountain ridges. All right, basically, what you have is the formation of these continents in a rapid movement going along the lines of electromagnetic force. Now, this is brand new, okay? I've seen some guys with a geologist working with the Thunderbolts project, one of the major electric universe guys. He's been talking about it. Another YouTuber, he's just been going over global, Google Earth and stuff like that, and kind of showing all these patterns and stuff. Also, you see them in mountain ridges. Sometimes you'll see these mountain ridges going, especially down over here. They saw some of those where they're just very triangular, actually. That's probably a better look at it. Let me see if I can found the illustration earlier. Let me see if I can find it now. All right, here we go. You can see how, look at these, creases going up and down and up and down. You could easily see how that could look like a current. Right. And that's just dug into the side of a mountain there. By the way, this is popular book, Walt Brown's In the Beginning, Compelling Evidence for Creation of the Flood. Now, another process that happens. Now, let me go back and kind of talk about what is happening, okay? Now, in the hydroplate theory, I think they usually start here. Okay, somewhere they'd say they're like the path of least resistance. But I'm going to start right here. Okay, just because of this massive amount of lava that's flown, all that volcanic activity. I could see where this crack is starting right here, and it would create these ridges. Going back to an earlier episode, we talked about how there are subterranean waters. These waters would be highly pressurized because of the miles deep crust, and so we got so much gravitational pressure. But now we've had this gamma ray burster get sucked in through the Earth's magnetic field, through the Earth's magnetic North Pole, into the Earth, and now the explosion, I believe, would start there. So, in other words, Iceland didn't exist, and then Iceland existed, okay? And then the subterranean waters will pop out, creating the Earth's mid-Atlantic ridge, up and down here. They go other places, and we kind of scoom over down here and around there, up and around. And what it would do is it would start to shift everything over here over, shift things over here. As it's blasting through, basically the crystallized sand is kind of a result of that explosion there kind of coming out. And lots of different effects that we're seeing. Over here in England, you're going to see these chalk beds. You're going to see them over in Canada too, in other places of the world too. This is this nuclear force, this super powerful thing. When the fountains exploded, these subterranean waters would just gush out. This ocean would not have been as big as we think of it today. It wouldn't have been very deep at all. Probably been a lot of land and then some smaller oceans and seas and stuff like that all over the territory. And basically what happened, all right, the water is shooting out, coming over here, and this big thing is sliding on over. Well, as it's sliding over, look, all this mountain ranges here get tucked up under the pressure, okay? It's just pushing right in. And that plate's coming out, and it's shooting over, right? So we go back to the other side of the world, and it's pushing in here. Well, you know what we have around the Pacific Ocean? They call it the Ring of Fire. All this volcanic activity. Why? Because of all the pressure of these continental plates pushing up against there and ramming right into there. So that's where we're getting all this volcanic pressure at the same time. And we know that when we go underneath the Pacific Ocean, they've found sunken islands hundreds of feet down, but they're just flat. And they're flat because of the wind knocking everything out and sculpting the area. But how did the wind do that if those things are hundreds of feet underneath the water? Because the subterranean waters were underneath instead of above in the Pacific we know today. And so as we see this explosion and all that stuff happen, you find this rip within seconds. And I think Dr. Brown says that it would have blasted about 20 miles straight up. Now, 20 miles straight up, the problem is that you only got 2 miles of air. Okay? So then what's happening to the rest of the stuff? Well, a lot of it is blasting through, and we'll deal with some of that next class. But a lot of it's blasting through the atmosphere, blasting through the canopy, and it's freezing. And it's not just water, it's dirt and water and all sorts of stuff. And this stuff is spitting up, and it's turning into frozen comets and asteroids. So that's something we'll deal with a little bit in more depth next class. But, and it doesn't have to be just this area, okay, because the whole rip and everything is exploding everywhere. Oh, by the way, meanwhile, back at the ranch, you know, the seafloor is spreading. The ridges converge over here, and if they do, that should be spreading, and it's not, okay? So just kind of, you know, I just want to make sure that last argument gets in there. But what happens to the Earth while this is going on? Well, there's this process called liquefaction, okay? Liquefaction it's a very important concept. When you go over Utah, you might see all these little arrangements of these rocks shooting up in the air, and they look like sculptures. And all these weird formations in Utah of all these rocks. What's going on? Well, instead of that being a mountain that just got carved in by the wind, actually, all those formations were underneath the earth. And then when you had this layer of earth and the water shooting under there, it's pushing stuff up. Okay, so it plops in and it jams a rock up, and then that rock comes out. I believe he also makes that an explanation over here for what used to be called Ayers Rock, and now it's more popular to call it by its native name, Uluru. But it's like the biggest rock in the world. What is it? Well, they believe that it was jammed upwards, okay, by these subterranean waters. And you could see different rock formations like that all over the earth, and you're wondering, how did it get that way? Who made it happen? You know, the wind, you know, even the water has trouble making that happen. That's because that's what's going on underneath. These mountains, a lot of them get jammed upwards. We wouldn't have to deal with a lot of the mountain pressures that we have today trying to figure out the global flood, because a lot of them were shorter. And it doesn't matter anyway, because I already demonstrated how underneath the earth there's plenty of water. And so there's more than enough. There's oceans and oceans of water underneath the earth that it could accumulate and cover the earth. So basically, you're seeing that here. Now, there was a force that went up here, which I explained in the last class. But basically, with this current of all these mountains, that's jammed upwards. So those mountains were much smaller back during that period of time. Also in liquefaction, this would have made all these different columns and all that kind of stuff. All these rock layers everywhere, the rock layers are all mixed up and jammed up, okay? The geologic column is not explaining that. It's just saying billions of years. Oh, well, it's all churning. But the Great Flood explains that with liquefaction, because everything's hit forth with that energy, okay, and that energy's converting. You have these shock waves, and these shock waves are liquefying temporarily that rock, okay, and this happens during some of the more intense earthquakes, where a lot of objects with different masses and densities will float to the top that were underground. And I've seen stuff where they've had like septic tanks and stuff float out of the ground, because the ground during the earthquake had been pounded so hard and fast that it became as dense as a liquid. And so it really would remind you, today we see this a lot, quicksand. Quicksand also has that same consistency. And a lot of people don't know, but like with quicksand, you can sink, but you usually float right back up. Okay? And it's because of an issue of the density. So the liquefaction is mixing all these columns up, and that's why we see all the rock layers in the different places. Meanwhile, you have all this pressure on these forests, animals, and plants, and it's pressurizing them to the point where they're forming coal underneath the heat and the pressure. Because we think of that, just bam, the explosion, 30 nuclear warheads. I mean, just a huge amount of power destroying and flattening out these huge fields, these huge forests, all of a sudden smashed in. And so what do we see? We see these coal beds, we see these fossils that are all smashed, and all of them look like they've been through something, okay? And that will be another subject for that next class. But, or the class after, just depending, but either which way. You had the fusion of the radioactive elements. In other words, over in Russia, they have some different nuclear physicists have been able to use fusion to make different elements. So when you have this highly developed stuff, that's why we have radioactive elements, because the fusion and the pressure in the earth at that time was just such a powerful calamity that it fused different places with different, small amounts of elements fused together, and the radiation kind of falls off them essentially. Okay, it's like you smacked a big thing of sand together, and then the sand, let's say like it's wet sand, you smacked together and made a sand castle. The little pieces of sand are constantly falling off. All right, well, that is the continuation of this class, and we'll see you later for New Year's cosmology class.